Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Maths Chapter 5 Prime Time Part 2. Prime numbers. Guna and Anshu want to pack figs or anjeer that grow in their farm. Guna wants to put 12 figs in each box and Anshu wants to put 7 figs in each box. So Guna and Anshu, they want to pack figs that grow in their farm. Guna wants to put 12 figs in each box. Anshu wants to put 7 figs in each box. How many arrangements are possible? Think and find out the different ways how Guna can arrange 12 figs in a rectangular manner and how Anshu can arrange 7 figs in a rectangular manner. We have to think about different possibilities. Guna has listed out these possibilities. Observe the number of rows and columns in each of the arrangements. How are they related to 12? See this figure, these are the different arrangements. 12 figs are arranged in a rectangular manner. See the first figure here, 12 rows and 1 column. See the second figure, we have 6 rows and 2 columns. In the third figure, there are 4 rows and 3 columns. So, how are they related to 12? See the second arrangement. In the second arrangement, for example, 12 figs are arranged in 2 columns of 6 each. That is 6 into 2. That is 12. So, figs are arranged in 6 rows and 2 columns. Then, Anshu could make only one arrangement, 7 into 1 or 1 into 7. There are no other rectangular arrangements possible. See this figure. This is the arrangement of Anshu. She could make only one arrangement. We saw that the number 12 can be arranged in a rectangle in more than one way. As 12 has more than 2 factors, the number 7 can be arranged in only one way as it has only 2 factors, 1 and 7. So, here 7 has only 2 factors, 1 and 7. So, it can be arranged only in one way. But 12 has more than 2 factors, 1, 2, 3, 4, 6 and 12. So, it can be arranged in more than one way. Numbers that have only 2 factors are called prime numbers or primes. So, numbers that have only 2 factors, they are called prime numbers or primes. Here are the first few primes, 2, 3, 5, 7, 11, 13, 17, 19. Notice that the factors of a prime number are 1 and the number itself. For example, factors of 2, 1 and 2. Factors of 3, 1 and 3. Factors of 5, 1 and 5. So, the factors of a prime number are 1 and the number itself. What about numbers that have more than 2 factors? They are called composite numbers. So, numbers that have more than 2 factors are called composite numbers. The first few composite numbers are 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20. What about one which has only one factor? The number 1 is neither a prime nor a composite number. So, 1 is neither prime nor composite. A prime number should have 2 factors. How many prime numbers are there from 21 to 30? There are 2 prime numbers from 21 to 30, 23 and 29. How many composite numbers are there from 21 to 30? There are 8 composite numbers from 21 to 30. 21, 22, 24, 25, 26, 27, 28 and 30. Can we list all the prime numbers from 1 to 100? Here is an interesting way to find prime numbers. Just follow the steps given below and see what happens? So there is an interesting way to find prime numbers. First step, cross out 1 because it is neither prime nor composite. So first you construct a grid of numbers 1 to 100. Then cross out 1. Why? Because 1 is neither prime nor composite. So you just cross this. Here you cross. Then circle 2 and then cross out all multiples of 2 after that. That is 4, 6, 8 and so on. Why? Because 2 is the only prime number which is even. So you circle 2. You circle 2 and cross all other multiples of 2. That is 4, 6, 8, 10, 12, 14, 16 like that. All other multiples of 2 you have to cross. Then step 3, you will find that the next uncrossed number is 3. Then the next uncrossed number is 3. Circle 3 and then cross out all the multiples of 3 after that. That is 6, 9, 12 and so on. So you circle 3 and then cross out all other multiples of 3 like 6, 9, 12, 15, 18 like that. Then step 4. The next uncrossed number is 5. So circle 5 and then cross out all multiples of 5 after that. That is 10, 15, 20 and so on. So next uncrossed number is 5. You circle that. And then cross out all other multiples of 5. 10, 15, 20 like that. You cross. Then step 5. Continue this process till all the numbers in the list are either circled or crossed out. So this process you have to continue. Then you will get a grid like this. See the circled numbers. The circled numbers are prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. These are prime numbers. All the circled numbers are prime numbers. All the crossed out numbers other than 1 are composite numbers. This method is called the sieve of Eratosthenes. So the circled numbers are prime numbers. All the crossed out numbers other than 1 are composite numbers. 1 is neither prime nor composite. This procedure can be carried on for numbers greater than 100 also. Eratosthenes was a Greek mathematician who lived around 2200 years ago and developed this method of listing primes. Guna and Anshu started wondering how this simple method is able to find prime numbers. Think how this method works. Read the steps given above again and see what happens after each step is carried out. Figure it out. We see that 2 is a prime and also an even number. Is there any other even prime? No, 2 is the only even prime number. All other even numbers are divisible by 2, making them composite numbers, not prime. Prime numbers are numbers that are only divisible by 1 and themselves. Since 2 is divisible by itself and 1 and it is also even, it is a unique even prime. A prime number has only 2 factors, 1 and the number itself. So 2 is a prime number. Prime number also it is an even number. But if you take any other even number, for example 4, the factors of 4 are 1, 2 and 4. So more than 2 factors. So it is a composite number. If you take 6, the factors are 1, 2, 3 and 6. So there are more than 2 factors. So 6 is also a composite number. So 2 is the only even prime number. Look at the list of primes till 100. What is the smallest difference between two successive primes? What is the largest difference? So first we can list the prime numbers up to 100. This is the list of prime numbers up to 100. 2, 3, 5, 7, 11, 13, 17, 19, etc. up to 97. Now let's find the difference between consecutive prime numbers. Consecutive prime numbers are those prime numbers that follow each other in sequence. So here 3 minus 2 is equal to 1. Then 5 minus 3, 2. 7 minus 5, 2. 11 minus 7, 4. 13 minus 11, 2. Like this, you have to find the difference between consecutive prime numbers. So the smallest difference is, we can see that the smallest difference between two consecutive primes is 1, which occurs between the prime numbers 2 and 3. So, what is 3 minus 2? That is 1. So, the smallest difference occur between the prime numbers 2 and 3. The largest difference between two consecutive primes below 100 is 8, which occurs between the prime numbers 89 and 97. 97 minus 89 is equal to 8. Are there an equal number of primes occurring in every row in the table on the previous page? Which decades have the least number of primes? Which have the most number of primes? The sieve of Eratosthenes does not necessarily have an equal number of primes in every row. Decades with the least number of primes, 91 to 100. See, from 91 to 100, there is only one prime number, that is 97. So, decades with the least number of primes is 91 to 100. There is only one prime number, 97. Decades with the most number of primes, decades 1 to 10 and 11 to 20. See this decade 1 to 10, it has how many prime numbers? 4 prime numbers, 2, 3, 5 and 7. Then from 11 to 20 also 4 prime numbers, 11, 13, 17, 19. So decades with the most number of primes, decades 1 to 10, that is with the prime numbers 2, 3, 5, 7, and decades 11 to 20 with the prime numbers 11, 13, 17, 19. So both have 4 prime numbers each. Primes through ages. Prime numbers are the building blocks of all whole numbers. Starting from the time of Greek civilization, more than 2000 years ago to this day, mathematicians are still struggling to uncover their secrets. So prime numbers are the building blocks of all whole numbers. Food for thought. Is there a largest prime number, or does the list of prime numbers go on without an end? A mathematician named Euclid found the answer, and so will you in a later class. Fun fact, the largest prime number that anyone has written down is so large that it would take around 6,500 pages to write it. So they could only write it on a computer. Which of the following numbers are prime? 23, 51, 37, 26. 23 and 37 are prime numbers. They have only two factors, 1 and the number itself. 51 and 26 are composite numbers. They have more than two factors. Write 3 pairs of prime numbers less than 20 whose sum is a multiple of 5. So we have to write 3 pairs of prime numbers. The prime numbers must be less than 20 and their sum is a multiple of 5. So multiples of 5 are 5, 10, 15, 20, 25 like that. So the 3 pairs of prime numbers less than 20 whose sum is a multiple of 5 can be written as 2, 3. So 2 and 3 are prime numbers less than 20. Their sum is 2 plus 3 is equal to 5. It is a multiple of 5. The next pair 7 and 3. 7 and 3 they are less than 20. Their prime numbers less than 20. 7 plus 3 is 10. It is a multiple of 5. Then another pair 2 and 13. They are prime numbers less than 20. What is their sum? 2 plus 13 is 15. It is a multiple of 5. The numbers 13 and 31 are prime numbers. Both these numbers have same digits 1 and 3. Find such pairs of prime numbers up to 100. 13 and 31. Both are prime numbers. They have same digits 1 and 3. Likewise, 17 and 71. Both are prime numbers with the same digits 1 and 7. Then 37, 73. Both are prime numbers with the same digits 3 and 7. Then 79 and 97. Both are prime numbers with the same digits 7 and 9. Find 7 consecutive composite numbers between 1 and 100. So composite numbers, they have more than 2 factors. So we have to write 7 consecutive composite numbers. Consecutive composite numbers means they follow each other in sequence. So 7 consecutive composite numbers between 1 and 100 are 90, 91, 92, 93, 94, 95, 96. These are 7 consecutive composite numbers. Twin primes. Twin primes are pairs of primes having a difference of 2. So, twin primes are pairs of prime numbers that differ by 2. For example, 3 and 5 are twin primes because 5 minus 3 is 2. Then, so are 17 and 19. What is the difference? 19 minus 17 is 2. So, twin primes are pairs of primes having a difference of 2. Find the other twin primes between 1 and 100. Twin primes between 1 and 100 are 3, 5, then 5, 7, 11, 13, 17, 19, 29, 31, 41, 43, 59, 61, 71, 73. Identify whether each statement is true or false. Explain. There is no prime number whose units digit is 4. This statement is true. No prime number ends with 4 because a number with a unit digit of 4 is divisible by 2 and is therefore not prime. A prime number has only 2 factors. The 2 factors are 1 and the number itself. So, this is true. Next one, a product of primes can also be prime. The statement is false. If you multiply two prime numbers, the result will have at least two distinct divisors, the two prime numbers themselves. This means the product cannot be a prime number. For example, consider 2 and 3. 2 and 3 are prime numbers. What is their product? 2 into 3 is 6. But 6 is not a prime number because it has more than 2 factors. It is divisible by 1, 2, 3 and 6. So, the product of 2 or more primes is always a composite number. Prime numbers do not have any factors. This statement is false. Prime numbers have exactly 2 factors, 1 and the number itself. All even numbers are composite numbers. This statement is false. Why? The number 2 is an even number, but it is a prime number. It is the only even prime number. 2 is a prime and so is the next number 3. For every other prime, the next number is composite. This statement is true. For all prime numbers other than 2 and 3, the next number is composite. For example, Prime number 5. The next number is 6. It is a composite number. Prime number 11. The next number is 12. It is a composite number. Which of the following numbers is a product of exactly 3 distinct prime numbers? 45, 60, 91, 105, 330. So, which of these numbers can be expressed as a product of exactly 3 distinct prime numbers? Let us break down each number into its prime factors. So, 45 is equal to 3 into 3 into 5. 60 is equal to 2 into 2 into 3 into 5. 91 is equal to 7 into 13. 105 is equal to 3 into 5 into 7. 330 is equal to 2 into 3 into 5 into 11. From the prime factorization, we can see that only 105 is the product of exactly 3 distinct prime numbers 3, 5 and 7. So, 105 is equal to 3 into 5 into 7. So, exactly 3 distinct prime numbers, product of exactly 3 distinct prime numbers 3, 5, 7. How many 3-digit prime numbers can you make using each of 2, 4 and 5 ones? So, by using these 3 digits 2, 4 and 5 ones, how many 3-digit prime numbers can you make? Answer is none. To be a prime number, a number must only be divisible by 1 and itself. If we use the digits 2, 4 and 5 to form a 3-digit number, any number we form will be divisible by either 2 or 5, making it not a prime number. See, the numbers 245, 254, 425, 452, 524, 542. These numbers are either divisible by 2 or 5, so they are not primes. Observe that 3 is a prime number and 2 into 3 plus 1 equal to 7 is also a prime. Are there other primes for which doubling and adding 1 gives another prime? Find at least 5 such examples. 3 is a prime number. When you double 3, what you will get? 2 into 3 is 6. Then add 1 to 6. So, 1 plus 6 is equal to 7. 7 is also a prime number. So, we have to find out some numbers, prime numbers for which doubling and adding 1 gives another prime. See, here are 5 prime numbers for which doubling and adding 1 results in another prime. 2. 2 into 2 is 4. 4 plus 1 is equal to 5. 5 is a prime number. Then 3 is a prime number. 2 into 3, 6 plus 1 is equal to 7 is also a prime number. Then 5. 2 into 5 plus 1 is equal to 11. It is a prime number. Then 11. 2 into 11 plus 1 is equal to 23. It is also a prime number. Then 23. 2 into 23 plus 1 is equal to 47. It is also a prime number. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see in the next video. Thank you.